Hey everybody, it's Mr. Conway. I'm going to start perception. So let's look at 4.5 perceptual organization and printed page 151. Okay, so we are officially done with sensation. So now we're going to switch from that detection mode into interpretation mode or organization mode. Okay, so now we're focused on top down processing, where top is going to mean that we're starting with the brain and we are looking at how we interpret and organize all of that stuff that our senses had sent up to us through bottom up processing. So now this is going to look like we're going to be looking at a lot of pictures and visuals and how the brain organizes things. And the first one we're going to start with is Gestalt. Okay, that's that G word right there. And it is a German word that means whole. So when we're using Gestalt organizational principles, that we are looking at the whole thing. We're not really interested in separate parts. We're going to look at things, we group them together. All right, so that first one right there, that figure 4.31, we looked at this in class. The Gestalt principles of closure would help us fill in these gaps and make a cube out of it. Okay, this is technically just a bunch of, this is 8 circles that are put that have these white lines in them. This is not actually a cube, but they're arranged in a certain way that your brain fills in the gaps and makes it a cube based on your prior knowledge of what a cube looks like. So this is intentionally manipulating your brain. So let's look at some of these um, ways that so some of these Gestalt principles. Okay, the first one that we're going to look at is actually Figureground. I really love Figureground stuff. It's typically going to be in black and white, and you will have one of these on your test. And a lot of things, really, just what you need to know is that Figureground is made up of a continuously reversing um, image that has the figure, which is what pops out at you first, and then the ground, which is what sits in the background. So you can only see technically one at a time. You can sometimes see them both, but for it to be figure ground is you kind of have to focus on one popping out, and that's the figure, and then the ground is what's in the back. Okay, so what's cool about figure ground is that you can continuously reverse them so that they're going back and forth, back and forth. So this one, figure 4.32, you should see the arrows. That could be your figure, and then the black um, fireman is the background. And then I can, if I decide to focus on the black fireman, I can see that the arrows are no longer popping out to me. They are in the background. So it's constantly a reversing back and forth. Okay. A really important page and paragraph right here is the grouping. Okay, this is your Gestalt principles. Be familiar with all 4 of these, and even the one of closure that's listed there at the bottom. Okay, so actually there's 5: proximity, similarity, continuity, connectedness, and closure. All right, these just explain how the brain organizes things if they fall into one of these categories. So, for example, proximity, if you look at figure 4.33, we don't see that as 6 separate lines. All right, the brain sees these as separate wholes. So what that does is it actually pairs, since those lines are they're in pairs. Okay, we actually look at the gaps as being the way that we kind of separate them. So we would see this as 3 groups of 2 lines. Okay. Same thing if you were sitting close together in groups. That would mean that I see, when you all are in your groups, I see eight different groups because you are in close proximity to each other. You are um, you're separate from each other. Okay, similarity is exactly what it sounds like. We group things that are alike. So if we're looking at this triangle, circle, triangle picture in figure 4.33, we don't group it horizontally. We group it vertically in our mind because that's what what we group them because they're alike each other. Um, so we look at those as vertical lines of a triangle, vertical lines of a circle, vertical lines of a triangle. Continuity just states that this is going to be a continuous motion. I think I drew in class how this could definitely be separate semicircles that are just kind of put together, but we see it as a continuous wavy line and a continuous straight line. We don't see that as separate pieces. And then connectedness, this one's pretty self-explanatory. If something is connected by a line, it automatically in our brain, we just think that it belongs together. Closure is the one that we looked at with the cube as well. We fill in gaps to make things that are whole. So this one, the picture right under the closure paragraph has these circles that are missing pieces of them, and we see the triangles that are within those circles. Okay. Let's keep on going. Let's talk about depth perception. Okay, we did this for our warm up. Okay, depth perception is it lets us see three-dimensional objects and how far away from them we are, or how far away from a car we are, how high up we are. That's all depth perception. And the big thing with depth perception is the visual cliff experiment. Eleanor Gibson conducted an experiment where she had the babies. She wanted to see if depth perception is innate. There's that word again. She wanted to see if babies are born with the ability to perceive depth. So she put them on a table and had a piece of glass that extended from the table. So a baby doesn't know that that's a piece of glass and they can walk on it. Okay, so the baby recognizes that, oh, hey, the table is stopping here. This is a cliff. If I walk over this, I'm going to fall. And the babies actually stop and they don't go over it. So that leads us to believe that we are born with an innate ability to perceive depth. Okay? Now, when we perceive depth, we have two types of methods that we use. We have binocular cues and we have monocular cues. Binocular cues are, we use two eyes to judge the distance of nearby objects. The cue that we use is called retinal disparity. This says that our disparity means there's a gap or a difference. So retinal deals with the retina, which deals with your eyes. Okay, so retinal disparity means that there's a difference between your retinal images. And it makes sense if you think about it. You have two eyes, meaning your brain is getting two different versions of what you're seeing. And so what the brain has to do is it has to kind of smooth out that disparity and create one image. Now, the closer things are to your face, the larger the retinal disparity is. That's why you see your nose in your line of sight, because it's so close. Your nose is on either side. If you blink each eye, you can actually see your nose switch from one side to the other. That's because the closer to your face is, the difference the images from your two eyes are. And the further away it is, the smaller the retinal disparity is. But that's your only really binocular cue that we're going to look at. Monocular cues are things that are ways that we measure distance and depth, but we only need one eye. So things like the big one in class, if you look at figure 4.38, the big one is going to be linear perspective, okay? But I want you to read over all of these: relative height, relative size, relative motion, interposition, and light and shadow. So check these out. These are pretty cool. So these are ways that we don't need both eyes to do this. We can just do it with one eye. And that's called a monocular cue. Now, we perceive motion in different ways, all right? There's a lot of things that we see as moving, but they really aren't. So like cartoons, old school cartoons like Tom and Jerry or Looney Tunes use something. I'm on 4.5.3, motion perception, printed page 155. If you go down to the fourth paragraph, it talks about, in parentheses, stroboscopic movement. That's going to be like when you make a flip book in class of somebody like jumping off a cliff and they fall and you have a parachute or something like that. People that make flip books, old school cartoons were done using stroboscopic movement. Stop, what are those called? Like Robot Chicken, where you do animations where you move them one little thing at a time, and then it could be hundreds of little movements, and then you play them in sequence and it looks like that they're actually moving. So that's going to be stroboscopic movement, okay? The other one is going to be the phi phenomenon, or phi, I don't really know how to say it, PHI. And this is going to be when lights blink in succession, and it appears to be that the light is actually moving But what it's doing is that certain lights are turning on and certain lights are turning off, and then it keeps going in that direction. And it appears that that light is moving, but it's not. It's just lights are turning on and off in sequence, and it makes it look like the light is actually kind of moving. So these are all illusions. Movement's not actually happening, but we perceive that it is. All right, the last thing that we're going to look at with perceptual organization is constancy. Constancy, most people get this word because it sounds like another word that we know, which is constant or consistent. So this means that the brain can keep things like shape, size, color, brightness. We keep these constant in our brain, even if there's an illusion that these things change. So for instance, when a door opens, if you look at figure 4.41, that rectangle door turns into almost like a trapezoid as it opens. And I showed you in class when I drew it, it's right. I have to move the angles of the door. It's no longer a rectangle, but our brain knows that it stays a rectangle. It's not changing shape, it's just the angle. It's our perception of it's changing, but your brain knows that that's still going to be a rectangle. Okay? So that's shape constancy. Size constancy is going to be like these illusions 4.42, where converging lines form distance, right? The further down the lines converge, the greater the distance. So when we put two similar objects on that plane of converging lines, the one that's in the back or on the top always looks like it's bigger because our brain thinks that that's further away. And for it to be the same size and be further away, that means that it must be really, really big. And we're going to watch, I've got something to show you next class or when we do our review that's going to help with this. So that's our size constancy. Okay. The other thing is going to be lightness constancy and brightness, and then color constancy. So we know that when you turn the lights off, colors don't change. They appear to change. They may look darker, but we know that it's still going to be the same color. When the sun goes down, your car is still the same color, even if it doesn't look as bright. Okay, so when things don't appear as bright as they once did, we don't freak out. We know that we keep that we know that when we turn out a light or something's in shadow, that it's not actually changing color. So this is going to be we have lightness and brightness constancy, and then we also know that our colors don't change. Just because it appears that they're in shadow. Our colors are actually staying the same, which is also going to be, that's your color constancy. All right, so that's going to be it for perceptual organization. And what we'll do is we will start with perceptual interpretation next time. Thank you.